morning. I hope everybody's enjoying sleeping in a little bit, but it's time for geometry. Today we're going to be talking about problem solving with proportions. Yesterday we looked at the plain math. Today we have a lot of very practical examples that we need to talk about and go through so that you can see that these things are really very, very useful. So we're in Chapter 8, Section 2. And we have two more properties that we need to talk about first. Okay, the first one is called the interchange means property. If you remember from one of your other math classes, we have the means and the extremes and the proportions. And basically what the interchange means property says is that if you have a proportion like this, A over B equals C over D, then it's okay to switch the positions for C and B, just like this. The C can come down here and the B can go up here. For those of you that remember yesterday or Friday when we talked about the cross product property, you should be able to easily see that you still have the same cross products. AD equals BC, just like over here, AD equals BC. So that's one way to think about why the interchange means property makes sense. What I do want to show you, though, is that we have a way of doing a quick little algebraic proof to show that this actually does come out to be true. So let's do this one step at a time when we're trying to prove the interchange means property. So here's our beginning part. So that to be said, if we multiply both sides by B over C, we get the B's cancel out here, the C's cancel out here, okay, the B's cancel out here, the C's cancel out here. We multiply both sides by B over C, and we end up with A over C equals B over D. All right, once again, you can always multiply both sides of an equation by the same thing. And we're multiplying both of these by B over C so that the B's will cancel here, C's will cancel here, and get A over C equals B over D. It's good to be able to think through what has to be true. As a matter of fact, the first few questions on the homework is asking whether something has to be true or not. You're not going to be asked to be doing any formal proofs on this, but it's good to be able to think it through as far as convincing yourself that a certain equation is true. Okay, here's another property. If A over B equals C over D, in other words, we have a proportion, it's also true A plus B over B equals C plus D over D. Okay. Once again, I want to do just a quick little thing to show you why that's true. Okay. All right, so we're trying to work on this. So we have to start with the hypothesis of this biconditional statement. And as we looked before, it's always okay to add the same thing to both sides of an equation. Now, this case, I'm going to choose something you may not have thought of. I'm going to choose a 1. Okay. Everybody could agree that if you add 1 to both sides of an equation, you still get the same value here. It's still equal. Now, I'm going to change the way this 1 looks. I'm going to change the way this 1 looks. I'm going to change the 1 on this side into a B over a B. Change the 1 on this side into a D over a D. Okay, we all know that anything over itself is 1. Anything over itself is 1. So I just put in an interesting form of 1 in this equation. So when you do that, A over B plus B over B, the denominators are the same. That means I can write this as one fraction, as A plus B over B. These denominators are the same, so I can rewrite it as C plus D over D. And that's exactly what we were looking to find in the first place. So once again, these are a couple of Nice quick little proofs, if you want to call them that, to show why these two particular properties are true. Now, when you do problems, you're more likely to use the interchange means property. However, today our problems really aren't going to focus so much on either one of those properties, but you need to know that they exist and that they're actually true. Okay, so we're going to look at some very common ratios today and how to do some proportions regarding those ratios. First one I'm going to take a look at, we're coming up on baseball season. The snow is going to end soon, hopefully, and we'll have some nice baseball going on. And during that, you're going to hear some statistics. One of those statistics is batting average. And a batting average will compare a number of base hits to the number of times a person's at bat. Okay, so that's our definition of our batting average ratio, comparing the number of times they get a base hit compared to the number of times at bat. So when you hear that somebody has a certain batting average, it's really telling you basically a percentage of the time that they get those base hits. So let's look at this person, Pat. Suppose Pat has a batting average of .273 and was at bat 150 times. How many times did Pat get a base hit? We can set that up as a really nice simple proportion, nice simple ratio problem. Okay, it says the ratio comparing the number of times they get a base hit compared to the number of times at bat. So here's the batting average, that's .273. So 0.273, the batting average. Number of times the batter gets a base hit, we don't know. It's saying how many times that they get a base hit, divided by the times that they're at bat, 150. Alright, so we have a nice little equation that we can solve here. The hits to the at-bats. I used a B before, but that's okay. Whatever variable you want to use here is fine. Same equation. Number of hits to the number of at-bats. A little bit of simple algebra. Multiply both sides by 150 to cancel out. Now the number you'll get will be a decimal, but you can go ahead and round that. And we find out that Pat was at bat 150 times and got 41 hits to have that batting average of .273. Okay, so now you have a little bit of an idea what those people, the announcers, are talking about when they are talking about batting average. So that's a very practical something, and you may or may not want to do those calculations, but it's kind of nice to at least know and have an idea of what they're talking about. Okay. Another thing that you may or may not realize is that there are standards to various different things that you encounter. One of them is the standard ratio for the width to height of a U.S. flag. Okay, that standard ratio is 1 to 1.9. So every time you have a flag that is 1 foot tall, it's 1.9 feet wide. So if you're following the standards of respect and you're trying to construct a flag, and you have a certain amount of material, this ratio is respected whenever the flag manufacturers make that. So if they want to make a flag that's 3 feet high, they'd have to calculate how wide it's supposed to be. So if we're comparing height to width, our ratio is 1 to 1.9, just as I stated here. And we know that the flag is 3 feet high. Remember, in a proportion problem, if you have height over width on one side, you have to have height over width on the other side. So here's the way our problem would stack out. Height actual height of the flag is 3 feet, and we have the width as unknown, and we have to figure out then what W is. A little simple cross multiplication. We end up 1 times W, 1W equals 3 times 1.9. Use your calculator and find out that that flag has to be 5.7 feet wide in this particular problem. Alright, here's another very useful thing to think about. Some of you are going to be traveling in your life. I just gave an exchange rate in this particular problem of Dominican pesos to US dollars. Our seniors were just in this very situation. It was about 429 to 1. Okay, 429 pesos to a dollar. Okay, so you go into the stores and you start seeing things written out in pesos. You should have an idea of how much you're paying in dollars. Now, we did a little bit of estimating when we were on our trip to make it just a little bit easier. However, if you wanted to find out an exact amount, I want to show you how to do that calculation. Very, very useful. Many of you will be out of the country at some point and need to be able to think through these conversions. Okay, we're talking about proportions once again. So if we're comparing pesos to dollars, you start off pesos to dollars with your fraction, your proportion. You need to figure out what's on the other side of the proportion on this. Remember, it'll be pesos to dollars. You paid 100 pesos, so the 100 would go up here. Okay, pesos over dollars on this side, pesos over dollars on this side. Quick cross multiplication problem. 429D equals 100. Divide both sides by 429. Be careful, a common mistake is putting the wrong thing in the calculator first. Remember, you're dividing by 429. So remember that 100 has to go in there first. And you get 0.23 and a bunch of numbers after. Now, you know in money, we end at the hundredths place, pennies. Okay, so this is 0.23, 23 cents. All right, this is a dollar conversion, so 23 cents. If you paid 100 pesos for a drink, you would have really paid 23 cents for that drink. And you need to make sure that you review in your mind when you're talking about money. Make sure you're rounding to the correct place value. Don't round it out here to the thousandths place or the 10,000ths place. Don't just round it to the tenths place. All right, when you do this on a test or quiz, make sure that you're always rounding to an appropriate place value for what you're converting to. Okay, so 23 cents for that drink that somebody may have bought in the Dominican. I know we did this a little bit earlier in the year, but to review, you could have a scale drawing, and those scale drawings have a scale factor. This one says the scale is 1/16 of an inch on the picture compared to 1 foot in real life. So let's say you take your ruler and you measure the width of this house, and you find that it's 2 inches long on the drawing. So if it's 2 inches long on the drawing, our question is, how wide is the actual house? So let's take a look at how we need to set that up. Okay, we measure the 2 inches. If we have the drawing compared to reality, 1/16 of an inch on the drawing equals 1 foot in reality. So this 2 inches here in the drawing equals unknown in reality. Drawing to reality, cross multiply, and you get 1/16 W equals 2. Once again, be very careful. We're multiplying both sides by 16 here to get 32. Some of you will say, wait, I have something multiplied here, I need to divide. Yes, divide, but be very, very careful. A common mistake people make would be thinking divide by 16. You're not dividing by 16, you're dividing by 1/16. So if you're choosing to do the dividing method, make sure that you're careful with your calculator. Divide by 1/16, put that in parentheses so that you get the 32 feet. A good knowledge of fractions, though, is going to save you a lot of heartache in that. You should make it your point to go back and re-understand your fractions well enough to know that 16 over 1 is the reciprocal of 1/16. And that will solve all those problems that come about when people make some of these common mistakes. So multiply by 16, you get 32 feet. Very practical examples in this section. All right, we have one more for the day. Wheelchair ramps. You probably see them, you take them for granted a little bit and don't think that there's actually a standard to them, but there is a standard. Slope of a standard wheelchair ramp is 1/10. Here's that slope that you've been seeing for years and years. Slope, remember, is rise over run in math and on your coordinate planes, but it really has real life applications. The slope of a standard wheelchair ramp is 1 to 10, rise over run. So let's say you need to build a wheelchair ramp that lifts the chair 3.5 feet. You need to figure out how much room you would need in order to build that ramp. I want to go up 3.5 feet. Okay. How much room do I need? How far from here to here how much space do I need in order to build this ramp so that I can safely get the person up the ramp? If you make it too steep, it's going to be too hard to push a person up that wheelchair ramp. If you make it too shallow, you're going to be pushing longer than you need to. 1/10 works out very well. So we're looking for the run if we know the rise. Another fair question would be how high will you be able to get the person lifted if you know how long it is, what the run is. So this is the rise of that ramp, and this is the run of that ramp. Rise over run, 1/10. So we set up our equation like this. Rise over run. 3.5 is the rise, how far up the wheelchair needs to go. I'm letting R equal run. And once again, you do the equation like you usually do, cross multiply. 1R equals 10 times 3.5. And in this case, you need 35 feet of horizontal distance in order to make that wheelchair go up 3.5 feet. Okay, so that's an interesting thing. It's something to think about. If you ever find yourself in a situation where you need to plan for that in your home, think about how far. You may even have to loop it around so that you have enough space if you don't actually have a complete 35 feet in one straight line. So very, very useful things today. And your assignment for tomorrow is to make sure that you complete the next assignment, number 45. And we'll see you tomorrow, God willing. Have a great day.